So let's look at another type of loop. This is going to be the infinite loop. And by the way, that word should scare you. Infinite. Infinite really means it's going to go forever. Remember, a loop will go as long as the condition is true. So what happens if I actually make the condition true? So let's think about that. If I say while true, print all is well, how is it going to stop? Well, it's going to run forever unless I make it stop. And obviously I could close idle, but Control C is the command that causes the keyboard interrupt. Control C will actually almost kill any command line program, including Python programs. And so Control C is how you stop a runaway loop. But let's run it again. But before I run it again, now I want to keep track of how many times this runs. So let's print out the number. And now we'll say all is well. And then we increment our number. And so you can see it's just going to go and it's just going to go. If you're ever feeling bored and you want to just let this run on your own computer, be curious to see, like, if you go out for like dinner tonight and just let this run, you know, what the number will be when you get back. But it's just going to go and go and go and go. And it's not going to stop until I force it to stop. And theoretically, it would run forever, right? This is called an infinite loop. It can run forever until the end of the world, as long as your computer is connected to a power source and your computer doesn't reboot. Of course, my computer rebooted this morning thanks to Microsoft, so that's usually not going to happen. But the computer will run that forever. So how else can I stop it? Well, if I want an infinite loop, and sometimes there's a reason why you might want an infinite loop, there is a way to stop a loop as it's running. And we can do that from within the loop. So in fact, let me just pull up the code from previously. And now I want to stop the loop. And I'm just going to do 100 because I don't really want to sit here forever and wait for 1,000. When it hits 100, the loop is going to stop. So now it's going to run. It's 100. Actually, it stopped at 99. Why did it only print up to 99? It printed up to 99 because it actually turned to 100 and break. That break actually automatically stops a loop instead of having to use Control C. So from a programming perspective, we use break to actually stop an infinite loop. And so you're probably thinking, why do I even want to do an infinite loop? Well, we can use infinite loops to clean up our game a little bit. Something that really bothers me as a programmer is the fact that I have this in here twice, because we call that repeated code. If I want to change the prompt, I have to change it in 2 places. If I want to say something else, it's in there multiple times. I mean, there's just a lot of things wrong with having duplicate code, and I don't like it. And the whole point of writing a loop is to repeat code. So there's the added benefit of less code, less makes it a little easier to read, a little easier to understand, and a little more streamlined, less possible bugs. So let's actually fix this code. Let me think about it for a second. I'm going to rewrite this, and I'm going to use an infinite loop. And now I'm going to just do the guess inside of the loop. And we know that's going to work, right? We know that's going to work. Except if I did this, it'll run forever. Well, we know we can put if statements in here. And what if we guess the secret word? How about we break? So now if they guess the secret word, the loop will end. Notice it's a little bit different. This is a condition. As long as they don't guess the secret word, we continue looping. Now, if we do guess the secret loop, we want to end the loop. Also, now I'm actually checking number of guesses greater than 0. We can break. And by the way, I could put those on an or statement and actually just have one line, but there's a reason I actually have 2 lines there, or a potential reason. If neither of those things happen, then we print the error message and it loops. So let's actually look now at the cleaner code. I was able to actually reduce some lines. But more importantly, I got rid of that duplicate code. So first try, they fail, that keeps going, we print. Second try, they succeed, loop ends, and we print. Run it again. Eventually they guess wrong, they guess wrong, they guess wrong. This goes to 0 now. We end and we print you lost. So we have a slightly more streamlined game here. Let's see. QWERTY, 1, 2, 3, 4, 5, 6. Oh, I got it. It works. Let's do it again. Let's do dragon. Dragon, dragon. So I went 2, 1, third guess, I lost. So I was able to clean up the code, get rid of the duplicates. I can actually clean this up a little bit further. Notice I have these 2 ifs, and I have this if. Do I really need 2 ifs? Probably not. I could clean this up unless there's something else I wanted to do. But I could have also cleaned that up by just putting them inside the ifs. Let's see, QWERTY. Hey, I got the answer right. Let's run it again. Dragon, figures, I got the answer right again, and I'm trying to actually lose the game. So one more, and lost. So it actually has the same functionality, but I've further refined the code a little bit to just reduce it. And now we have a pretty streamlined game there. So, I mean, I could have left that down there and I could have just used if secret word is true or this is true. I could have done that and just had a single break statement. But since I had multiple possible breaks in here, I could have also just merged them together. So just a couple of different ways of doing the same thing. Works exactly the same way. But, you know, this is a little bit of a different way of writing it because now we have this infinite loop and we don't have any duplicate code and we're using the break keyword to exit the loop. So this is one reason why you might want to, on purpose, use an infinite loop. Unfortunately, what usually happens to especially programmers in their beginning, or I've actually do this still, is that sometimes you get an infinite loop when you didn't want it to be an infinite loop. Think about the situation where you have num equals 0. Actually, let's do the other thing. Let's do num equals 10, and I want to do a countdown. While num greater than 0, print, actually, just print the number. And that's it. Will that loop ever end? Well, no, it can't end, right? This is an infinite loop. What's missing? I don't ever change that number. So this loop can never change. I'm missing the variable update. Without the variable update in the loop, this condition can never, ever be true, or sorry, ever be false. And therefore the loop won't. So this is an infinite loop. And an infinite loop with no update, no var update, which is a bad thing. It's a mistake we make all the time. Unfortunately, you just have to figure out how to stop it, go back and figure out, okay, I have an infinite loop, I gotta go fix this. By the way, one of the number one things that'll crash Gradescope is infinite loops. It happens all the time. You have an accidental infinite loop. You didn't run it on your own computer to see it. The Gradescope test causes it to go poof, and it just times out. That's usually because of an infinite loop.